Hi and welcome to section 1.1, examples 2, 3, and 4. We're going to do all three of those on this one video. Okay, so this one we want to determine the number of terms. So we've got the muskox and caribou of northern Canada are hoofed mammals that survived the Pleistocene era, which ended 10,000 years ago. In 1955, the Banks Island muskox population was approximately 9,250 animals. Suppose that in subsequent years, the growth of the muskox increased by approximately 1,650 per year. How many years would it take for the muskox population to reach 100,000? Okay, so the information here, this first stuff is just, interesting to learn. It tells us in 1955, they started with 9,250. So that's our T1. Okay, and then it tells us, just say that they go up by 1,650 each year, right? So that's our D. That's how much it's increasing each year. How many years would it take to reach 100,000? So it's asking for N. How many years is it going to take to get to 100,000? So what we do for that is our Tn will be that 100,000. So that number that we're ending at is our Tn. Okay, so then we just go to our formula and we can sub into it. So we'll have 100,000 equals Ti. I used to call it A back in Math 10. So 9,250 plus N minus 1 times by the amount that goes up each time by D, which is 1,650. All right, so if you're not sure what that formula is, look at the previous page. Okay, and now we just simplify this. So we're working this out here. I'm going to subtract the 9,250 over to the other side. Right, so I get 90,750. And then equals, here I distribute the 1,650 into there. So it becomes 1,650N, take away 1,650. Again, I subtract the 1,650. I get 92,400 equals 1,650N. And I just divide both sides by 1,650, and I get N equals 56 years, right? Because it's in years here, because it's going up by 1,650 each year. Okay, so it would take about 56 years for the population to reach 100,000. Okay, next example, and I'm sorry in yours I forgot to put this image into yours. So that's what the image looks like. You can also see it on page 13 in your textbook. So here, John has a job at a grocery store. He's been asked to create a display of cereal boxes. The top 6 rows of his display are shown. So these are the top rows. There's rows below this. The number of boxes in the rows produce an arithmetic sequence. There are 16 boxes in the 3rd row from the bottom and 6 boxes in the 8th row from the bottom. Okay, how many boxes are in the bottom row? Well, we actually don't know how many rows there even is. So what we want to know is what we're looking for really here is T1, right? What's T1? We're looking for how many boxes are in the bottom row. So T1, right, that will represent our bottom row. So instead of representing the top row, it'll be our bottom row. So that means we're going to be subtracting each time. Okay, from this picture, we can see how much each row goes down by. So for example, this row here is 4, this row is 2. So if we're moving from bottom to top, that means each time D is -2, because we're going down by 2 each time. Okay, so how are we going to find what T1 is? Well, what information do we have? Well, we know that there's 16 boxes in the 3rd row. So that tells us that T3 is 16. Okay. We also know that there's 6 boxes in the 8th row. So T8 is 6. So let's look at what this information gives us. So if T3 is 16, we could write a formula of 16 equals T1 we don't know, plus, and then N for that one, right? N here is that number there. It's 3 minus 1 times by -2. Looking at that, do we have enough information now to solve for T1? Yes, we do. So we just need to isolate the T1. So we have 16 equals T1 plus, over here we get 2 times negative 2, so 16 equals T1. Take away 4, because that's a positive 2 and a negative 2. And then we add the 4 to the other side, so we get T1 equals 20. Okay, you could do that same information with this one here, with the T8 equals 6, and you should find that it also equals 20. I did it, and in fact it does. Okay, so that tells us that if we were to extend this picture, right, if we extended this picture here, right, the bottom row would have 20 boxes, and then they lose 2 each row. So then part B says that determine the general term, which is Tn for the sequence. So it's Tn equals, okay, T1, which is 20, then plus n minus 1, and then our D, right, was negative 2. Could leave it like that, but we should simplify it. So that becomes 20 minus 2n plus 2. So that just simplifies to be 22 take away 2n. So there is our general term. And then part C, now we can use that. It says, what's the number of rows of boxes in his display? Okay, well, basically what we're looking for is what is n, okay? And in the top row, what's our actual term? Well, our term, right, is 2. So we know the last number in this sequence is 2. So we can go to our formula and we can have Tn, so that's 2 equals, and then based on this one above, right, it's 22, take away 2n, we just solve for that n, so we subtract the 22 to the other side, so we get negative 20 equals negative 2n, n equals 20 divided by negative 20 divided by negative 2 is 10. We've got 10 rows of boxes in this display. Okay, I know I went a little bit quick there, but hopefully you could follow it. If you didn't, right, just rewind it and listen to it again. Okay, example 4, we want to generate a sequence here. So here it says a furnace tech charges $65 for making a house call plus $42 per hour or portion of an hour. Okay, that sounds about right. It's very expensive. Part A, generate the possible charges, excluding parts, for the first 4 hours of time. So just for him to come to your place, what's it going to cost for the first 4 hours? Okay, so looking at this, what's the actual first term? Right, so he charges $65 for making the call, and then when he comes to your place, he's already coming for part of an hour. Right, so the first hour isn't $65. The first hour is actually 65 plus 42. So the first hour would cost you $107. So then what's the next one going to be? Well, the next one, we just add 42, so we get $149. Next one, we add another 42, $191. Next one, we add 42, $233. Okay, that's all that one's asking for. And then part B, what's the charge for 10 hours of time? Okay, so to figure that out, probably want to set up a formula. Right, so we have that T1, right, is 107. We have that D is 42, that's how much it goes up each hour. N, in this case, is 10, and we're looking for T10. Right, that's what we're looking for. So it's T10 equals 107 plus 10 minus 1 times by 42. We just simplify that out, put it in our calculator if we want to, or challenge our brain, and we get $485. So for 10 hours, it's going to cost you $485.